Hi, my name is Mark Leroux for Sylvia Findings, and I want to show you our OGI Jewelry Scan 3D scanner for jewelry parts. We have another scanner that we use for scanning stones, but that'll only scan stones, I mean, as small as 2 or 3 millimeters, but only as big as about 35 millimeters. It's super accurate, but it will only allow stones up to that big. If we have stones that are bigger than that, and I know you're thinking, who has stones that are bigger than 35 millimeters? Boy, trust me, I've seen some jewelry where the stones are massive, and you need to be able to scan those, for the 3D designs. But suppose you have a ring or a pendant and you want to recreate it in another alloy. Maybe you have it in sterling, but you want to have it in gold. Rather than having a CAD designer redesign this thing in a 3D CAD version, we can just scan it, and then this will produce an STL file that from that file we can 3D print a castable resin version and then cast it as it is. The casting or the scanning of this machine is super accurate, so details that might get lost in translation, because when the CAD designer is looking at a picture or something that you already have, you can never 100% accurately recreate every angle, every subtle nuance that you can if you have a 3D scan of the actual item, which is what this machine will do. So let me show you, do a little demo, show you how this works. So the first most important part of the scanning process is, of course, to calibrate the machine. We recalibrate it before every scan just to make sure everything is perfect. There's a calibration pad here that I'm just going to put in the machine, and then up here click that calibration, and then this will start sending information from the scanning pad up to the machine, making sure that everything is super accurate. And you'll be able to see it'll display up on the screen exactly how accurate the scan is. So this shows, you probably can't see it in the camera, but it shows accuracy 0.002554 millimeters. So within 2,000ths of a millimeter is how accurate the surface will show. So first things first, the jewelry scanner uses light and reflections of light to accurately scan the exterior surfaces of the piece that you're scanning. So reflective surfaces like silver, gold, don't work really well. So you need to have another coating on the surface, and you can buy a 3D scanning spray. You can just spray on the surface of that, and that will make the surface opaque. And I'm just going to scan the top of this for now, even on the inside. And that will provide a nice opaque surface for the scanner to scan. And I'm going to do just the top for now. We're going to scan separately to do the bottom, and I'll respray the bottom when we're done. So I've got my ring here that's been sprayed, and I've got the scanning pad. I'm just going to put this ring inside some blue tack, some poster putty, whatever you want to call it. And this will hold it into the pad. And that's it. I know you're thinking, but Mark, that's not going to make an accurate scan because half the ring is covered with this blue putty. It's not a problem, because the way this works is we're going to do a scan of the top half, And then we're going to take this out and reposition it in the blue tack and take another scan of the bottom half. And then the scanner will combine the two views of the scan and into a three-dimensional whole. Okay, we've got this ring blue tacked to the scanning tray, the scanning pad. I'm just going to put that on those magnets. That'll hold it in place. And I'm just going to start the scan. So you can see the different widths of black and white bars. That's what the scanner is using to calculate the reflections, the angles. So if it were a transparent or really reflective surface, it would change the shape because of how the light bends across it. But with an opaque surface, you don't have that. Now, this part is just telling you to tell the machine where the blue tack is, right? So you can see this is all blue tack. Here's kind of like a rudimentary scan of the ring, and we just need to elevate that up until we're all the way past the blue tack. And now it's only scanning the ring, or at least the top half of the ring. And what you see, there's a little bit of blue tack here. I can keep raising that up a little bit just to completely cover that. That's good. And I say okay. Now it'll start scanning the top half of the ring in earnest. This will take a few minutes as it goes through. You can see the areas here that are in red. That's what it's actually scanning. Slowly filling in bits and pieces as it goes. Now, what you're seeing on the screen is not ultimately what it's going to look like. These are very crude representations of the information that the machine is collecting. Almost done. Right now, as I'm going through, if I see some areas that I'm not happy with, like some of this area that's black in here, I can add a scan, reposition the ring so that it's looking right at the areas that I want to rescan, and it'll do a scan of that area, and then it'll add that area to the scan that we've already got. And we could just keep doing this over and over again until we're absolutely 100% positive that we have all of the surface covered. But I think really that's the only one that was making me think that maybe there wasn't. Let's see if we can add a scan. I think let's go with that. Right, so that's the first half. Now I'm going to take this off the blue tack and I'm going to rearrange it upside down, and then we'll take more scans of the underside of the ring and then it'll add those together. Okay, so I've got the ring placed upside down now, and I've touched up some of the spray on the ring band that got rubbed off, and I'm just going to tell this to play the next half, and it will now scan the bottom half of the ring. And it's kind of amazing because when the machine finds enough overlaps in opposite directions, it can add them together in super accurate way. And I know you're looking at this and you're saying, but Mark, that doesn't look accurate at all. This is really, really crude, very quick drawings that it's just putting on the screen. The scans that you'll see at the end are really super accurate and kind of impressive. Let me see. There's an area here that I'm not really happy with. This. Some of that on the inside there, that black area, maybe there's not enough information. So let's just say I want to add a scan, and we'll rotate it so that what we need is right in the view. It'll do just a quick scan of that area. You see it's oriented exactly the same way. And there, you see this filled that in? Beautiful. Maybe let's do one more of just that. Right, so it reorients the item exactly the way I wanted it, and it's filled in all that place. Now once I'm done, once I feel like there's enough information for it to create the perfect scan, I'll click the ready button, and now it'll align the top half and the bottom half together into a single cohesive whole, right? And now if I say good, now it will, from the information it has all of the little points, it'll call it wrapping. It'll wrap this in the in a bunch of polygons, two-dimensional polygons that will create the three-dimensional STL file. This takes a few minutes. So that's finished wrapping, and now you can see the, this is still kind of a crude view of that thing, but you can see it's much more refined. All the details are there. This will be saved as an STL file that you can 3D print directly to get an exact replica. And here's one that we printed, a version of this. You can see all the beautiful details there. The supports are still there from the 3D printing, but from here you can take this, if you print it with a castable resin like this, you can cast this in whatever alloy you want, and you'll have a perfect replica of your original copy. And that's basically it.